we're just going to do a couple more examples of the different types of word problems you're going to see for systems. Obviously not all the types of problems, but just to give you some more examples. So the infamous cow and chicken problem. A farm raises cows and chickens. And interestingly, the farmer has a total of 42 animals. All right, because remember, we got to do two things. One of the things is animals. And one day he counts all the legs of all the animals and has 114 legs. What? That's why I said this is infamous. How many cows does the farmer have and how many chickens? All right. So I can't, so we're going to find the number of cows, right? And maybe for cows, I'll say it's C. And for chickens, I can't use C again. So I'll say K. I don't know. Okay. So we have two things we're talking about here. We're talking about the total number of animals and the total number of legs. So let's start with the total number of animals. If we take the number of cows and add it to the number of chickens, it's going to equal 42. Legs. We know we have a total of 114 legs. Cows have how many legs? So there are 4 legs per cow. And chickens have how many legs? There are 2 legs per chicken. Yes, I know. So this problem right here is now we've set up the system to figure out how many cows the farmer has and how many chickens. Can we graph it? Yep. Put it in slope-intercept form or use one of the other methods, graphing or intercepts. Could we solve for a variable and use substitution? Yes. Am I going to do an elimination? I am. Okay. And again, you can look at any way to do it. Let's say we wanted to make the C's, the number of cows, opposite. So if this is 4, I need to make this a -4. If I need to make it a -4, that means I'm going to multiply everything by a -4. All right, so -4 times C is a -4C plus -4 times K, or 1K, is a -4K equals -4 times 42. Well, negative times a positive is a negative, and 4 times 42 is 168. Okay, so then I'm just going to bring over my 4C plus 2K equals 114. This gives me 0 C's. -4 plus 2 is going to be a -2K's equals -168 plus 114 is a -54. Since this is multiplying, we do the inverse, we divide. We're going to divide by a -2. Negative divided by a negative is a +1. Positive 1K. That's why we have to divide by whatever that coefficient is. Whatever I do to one side, I do the other. -54 divided by a -2 is 27. Okay, remember, was the number of chickens. So we have 27 chickens. Now, once we know how many chickens we have, we can find out the number of cows. So let's say I just take my original formula here of C plus K equals 42. K is 27, so I plug that in here, and I get C plus 27 equals 42. I'm solving for C, so I'm going to subtract 27 from each side. And 42 minus 27 is 15. So there are 15 cows. And there you go. If you know the number of legs and the total number of animals, you can figure out how many cows and chickens there are. All right, one more example, maybe a little more relevant. A friend bought 2 boxes of pencils and 8 notebooks. Cost him $11. So he went to back to the store the same day to buy school supplies for your younger brother. This time he spent $11.25, 3 boxes, 5 notebooks. How much would 7 notebooks cost? Well, before I can figure out how much 7 notebooks would cost, I need to know how much 1 notebook costs. We have 2 things going on here. We have the amount of things, and we have the cost. Okay, so I'm just going to use normal variables. 2 boxes of pencils plus 8 notebooks cost $11. Okay, this time we do know the cost for both of them, so that's why I'm not just going P plus N here. The second time there, he bought 3 boxes of pencils and 5 notebooks, and it cost him $11.25. Okay, now what we can do for this one is there's not a really good way to get opposites. Now, it's important to note that we have up until this point just been multiplying one of the equations, but there is nothing that says we can't multiply both of the equations. So that's what we're going to get a little taste of right now. I need to make opposites. So if I look at these, so when we look at our coefficients of p and our coefficients of n, what sticks out to me is that 2 and 3 here might be a little easier to work with because I know they both go into 6. And I just have to make one 6 and one -6. So let's say I choose to multiply this top one here. Well, I know I'm going to multiply this by 3 and this by 2. And then maybe I just choose to make this first one negative. You can make the second one negative. Okay? So it's just an example of how we can multiply both equations. All right? So if I go -3 times 2, I get -6p plus -3 times 8 is a -24n equals -3 times 11, which is a -33. Now down here, 2 times 3p is 6p. 2 times 5n is 10n. And 2 times 1125 is 2250, I'm pretty sure. It is. So that becomes $22.50. Now, guys, you don't have to do it like this. You could have worked with the ends and gotten opposites there. You could have made the bottom equation negative. It's okay, all right? Because as long as you do whatever you do one side, you do the other, it all works out. -6p's, +6p's, 0, gone. -24n plus 10n, that's going to be a -14n, equals -33 plus 2250 is -10.5 or 10.50. Okay, so now we're solving for n. So I'm going to divide both sides by -14. Okay, I'm going to bring that out over here. Negative divided by a negative is a positive, and if I take my calculator and I go 10.5 or 50 divided by 14, we get 0.75. So, and remember you represent notebooks. So notebooks are going to cost 75 cents each. Okay? So, we could figure out now how much a box of pencils cost. Except if we come up here, it says, how much would 7 notebooks cost? I'm not even interested in the amount of pencils. I could figure it out, but I don't need to. So if it's 75 cents per one notebook, we could go 7 times 75 cents. And I get $5.25. So again, it's really important to just make sure we're answering the question being asked. For the most part, most of the times you are going to be finding both values of the variable, but in this case, we are only interested in the notebooks. Also, just important to kind of keep out there as you deal with systems more later on, you can multiply both equations by the number as long as you do it to both sides, and that way you can get opposites and use elimination to solve.
I want to say now about math, and we have a new 7-year-old, which is my sister, Abby!
Jack wanted to give a quick shout out to Abby, who is 7 years old today. So we are going home to have some ice cream and cake, right?
And her birthday is later. See ya! Now I want to make up the title, okay?